Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about the importance of sanity check in machine learning. This topic is based on a tech blog with the title How to Streamline Machine Learning Model Development, Automated Sanity Checks, written by the machine learning team from Intuit. You can find the blog link in this episode's description. Throughout this episode, we'll dissect the topic from both business and machine learning angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Intuit is an American business software company specializing in financial software. It is valued at more than $180 billion market cap as of February 2024. Intuit has several products, and among those, two popular ones you may use in your life, including TurboTax, which is a tax preparation tool guiding individuals through tax filing and ensuring compliance. Another one is called QuickBooks, an accounting software helping small businesses in managing finance and generating reports. Within the company, machine learning plays an important role, contributing to improvements in various areas, such as transaction categorization, automating account tasks, and enhancing customer experiences. Typically, when people just get started learning machine learning, their attention tends to gravitate toward algorithm improvements. However, in reality, the process of successfully deploying a machine learning model and ensuring it behaves as anticipated is far from straightforward and comes with numerous challenges. For instance, a model that shows improved performance during offline testing may unexpectedly underperform once launched, and it may trigger numerous follow-up investigations. This holds particularly true for companies with many existing machine learning models already deployed at a large scale. This is where effective sanity checks play a pivotal role in mitigating such challenges. Now that we've understood the business problem to solve, let's shift gear and dive into the machine learning side to explore the proposed solutions. The team proposes leveraging automated sanity checks to address this challenge. In the development of machine learning, a sanity check involves conducting a series of preliminary tests and evaluations to quickly assess whether a specific aspect of the system is functioning as expected, or if any apparent issues exist. This process helps identify sources of systematic errors and bias during pre-production. Well, it's easier to understand potential errors or coding bugs. Let's take a look at what the bias mean here. Machine learning bias occurs when a model systematically produces prejudiced results in favor of or against a particular category of model input. To illustrate this concept, one such bias is sampling bias, introduced by differences between datasets used for offline training and compared to the online datasets your model encounters in production. Imagine you are developing a machine learning model. The model is to predict loan approval based on historical data. The dataset you have predominantly include loan applications from a specific demographic, such as individuals with high incomes and excellent credit scores. These applications consistently receive approvals for loans. In this case, the sampling bias arises from the fact that the dataset is not representative of the entire population applying for loans. It disproportionately includes applications who are more likely to be approved, potentially neglecting individuals with lower incomes or credit scores. Consequently, if you train your machine learning model on this biased dataset, it may learn patterns specific to the privileged demographics and may not be able to make accurate predictions for applications from underrepresented groups. The model might inaccurately assume that high incomes and excellent credit scores are the primary factors for loan approval, and this could lead to biased and unfair outcomes for those who do not fit these characteristics. Now that we know what is a sanity check and we recognize the importance of detecting issues and potential biases in the machine learning system, let's delve into the 4 general steps involved in the sanity check. Step 1 is to ensure that online model scores are stored in the output repository. This can serve as the fundamental step to guarantee the availability of ground truth data, so that this can be used for making comparisons against offline model performance. Step 2 involves rescoring the same prediction using the offline model, considering all the necessary inputs as if they were from the online model. This typically includes feeding a sample of the online input data to the offline model so that to ensure a consistent results can be carried out. The reason we use a sample of the online data is to be more resource efficient, given that the goal of this exercise is to detect issue rather than making the full set of prediction. Step 3 entails comparing the online model score to the offline model score, and to check the statistical characteristics of the online model score against the score in the offline dataset. If there is any noticeable distribution differences, then that could signal potential problems. By the way, it is important to note that the perfect accuracy is not expected. There is some tolerance for the difference to be happening, especially for models with stochastic nature. However, if a significant variance is uncovered and the difference is above a specific threshold, then further investigation is needed. Step 4 involves how to do this investigation. This includes checking all the input datasets for any significant variances observed between the online and offline models. This includes examining the characteristics of the input features fed into the models, and also can have a broad range of criteria, such as checking whether each feature, their distribution is the same or not, and whether the dataset is different or not. The objective is to detect the root cause, and a broader coverage of the investigation can usually facilitate a quicker identification of the root problem so that the team can make an action. With a clear understanding of these 4 steps, The team has developed automated tools around the needs of these sanity checks. And this could enable each step to function without human presence or active engineering engagements. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we discussed why Intuit leverages sanity checks for its machine learning system, some potential biases involved in the machine learning development process, and the steps to conduct a comprehensive sanity check to ensure streamlined machine learning deployment. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.